Hello students. So after completion of the chapter statistical discussion of data part 1, now we are going to start the chapter measures of central tendency part 1. Okay. So the chapter measures of central tendency we divided into two chapters, right? Like part 1 and part 2. So just we go to the discussion about the introduction of central tendency first. So what is central tendency? First we have to discuss about the what is a central tendency, then we discuss measures of central tendency. So what is meant by central tendency value, right? So central tendency. So already we know that the collection of information is nothing but data. So to study the nature of the data, the first measure we required, that is we have to identify the central tendency value. So what is that central tendency value? Means all the values surrounded by a particular value in the data, that value we call it as a central tendency value. That is, that value will be representative of all the observations in the data. That value will be acts as a representative value of that data. That is, we call it as a central tendency value. For example, suppose you are saying your percentage of the marks. Academic performance, you will represent it with your percentage of the marks. That means instead of saying each and every subject mark, you are saying your percentage value only. That single value will represent the entire academic performance by you, right? So that value we call it as a central tendency value. Suppose you want to say the economic development of a country, right? So instead of saying how a country is developed in agriculture sector, how a country is developed in industrial sector, how it is developed in service sector, how it is developed in some other sectors and each and everything, instead of saying all these things, just we represent how the development is with the help of a single value, that is the GDP value. So with the use of the GDP value, single value, we can get idea about the development of that country. Similarly, by seeing that value, we can get some idea about that data. That value we call it as a central tendency value. So that central tendency value always will be located at the central part of the data, and all the remaining observations will be surrounded by that value. That is, we call it as a central tendency. So every observation, that means instead of saying each and every observation, we represent with a single value. That is, we call it as a central tendency value. Now, suppose we collected the information, we have the data now. How to identify that central tendency value? That is, we required measures. Those measures we call it as measures of central tendency. Right. So how many measures of central tendency we have? So we have 5 measures of central tendency mainly. Those are, first one is mean, or also called as arithmetic mean, and second one is median, we denote with M. Of course, mean is denoted with X bar. And third one is mode, we denote with Z, and fourth one is geometric mean, that is G or GM, and fifth one is harmonic mean, H or HM. Of course, the main measures of average, the main measures of average. What is average? Means central tendency, also called as average. So to a layman, average means mean only, but a statistical person know that central tendency and average are both are same. Average means a single value which represents the entire data. Similarly, central tendency also is single value which represents the entire data. So central tendency also called as average. Now the main averages are mean, median, mode only, and again the mean, arithmetic mean is divided into, mean is divided into arithmetic mean, geometric mean and harmonic mean. So finally we can say that there are 5 measures of central tendency: mean, median, mode, geometric mean and harmonic mean. So in our masterminds material, latest edition, 5th edition material, we divided this entire chapter into 2 parts: the measures of central tendency part 1 and part 2. So in part 1 we discuss arithmetic mean and median, and along with median we have other positional measures like quartiles, deciles and percentiles. So up to other positional measures, that is come under measures of central tendency part 1, and part 2 will start with mode and include geometric mean and harmonic mean. So we divide it into 2 parts, right? Of course, first we discuss about arithmetic mean. So before going to arithmetic mean, we must know that very important point is, among all these measures of central tendency, the ideal measure of central tendency is nothing but arithmetic mean only. So we can say that mean. Of course, average refers to mean only, but average refers to mean, median, mode also. But generally, average refers to mean only, because mean is the ideal measure of central tendency. So why it is called as the ideal measure of central tendency? So we have a criteria and we have a different features to define an ideal measure of central tendency. That criteria means it has some conditions. So mean is satisfied most of the conditions, right? So that's why mean will become ideal measure of central tendency. So what are the different conditions? First we discuss briefly, and in second part we discuss in detail. So among all these measures of central tendency, mean is called as ideal measure of central tendency. Why? Because mean is first of all, it is rigidly defined. So what is rigidly defined means? That means it must have some standard definition, and universally everyone should interpret in the same manner. Then we can say that that measure is rigidly defined, and it should be based on all the observations. The measure of central tendency should be based on all the observations. That means while calculating that measure, we should consider each and every observation. I think everyone know that how to calculate mean, median, mode for a simple data. So in calculation of mean, we know that the general formula is sum of observations by number of observations. That means we will add each and every observation. What is that meaning? We are depending, while calculating mean, we are considering each and every observation. That means each and every observation will be taken into the account, so that we can say that mean is based on all the observations. But in case of median and mode, those two measures not based on all the observations. Why? Because median is middlemost observation, so we concentrated only on the middlemost observation. Of course, first we arrange the data in ascending order or descending order. After that, we identify the middlemost observation and we ignore the remaining all the observations. So what we conclude is median is based on only one single observation, that too middlemost observation only. So the second condition, that is the measure of central tendency should be based on all the observations, is not satisfied by median. Of course, in mode also we concentrated on the value which is repeated more number of times. That means mode is also not satisfied that condition. So among all the measures of central tendency, mean is only based on all the observations. Like that, so even one more condition I can explain now, that is the measure of central tendency should be easy to calculate and easy to understand. Mean is very easy to calculate and easy to understand. Everyone know that how to calculate mean. Even a non-mathematical person or illiterate people, they can use the word average. Suppose you ask a farmer, suppose he buy a bike, suppose you are asking about the mileage, what he will say, that is on an average I am getting 60 km per liter. So average, according to him, what is average is nothing but mean only. So everyone know that how to calculate mean. Suppose you give your marks list to your father or your parents. So just you tell me to ask them how just you calculate the average of my marks. So what they will do, they will calculate the mean only. They don't know how to calculate median and mode for your marks. Even they don't know what is how to arrange the data in ascending order or descending order, and they don't know the most repeated observation is called as mode. So everyone know that mean only. So why? Because mean is very easy to calculate and easy to understand compared to median and mode. Now even you compare for other type of data like discrete and continuous series also. The procedure for calculating median and mode for discrete and continuous very complicated while comparing with the procedure for calculating arithmetic mean for discrete and continuous data. So these are the important points. Like these points, there are so many points we discuss in the second part. So we consider as mean is ideal measure of central tendency. Now we start with the arithmetic mean, right? Simply we call it as a mean only. So what is meant by arithmetic mean? That is the first measure of central tendency. Of course, ideal measure of central tendency too, right? So what is arithmetic mean? Mean, that is nothing but the sum of observations divided by number of observations. That is we call it as arithmetic mean. Suppose we are having x is a variable. Now it is taking the values x1, x2, x3, so on, xn. Let it be n observations I am having. So how we can calculate arithmetic mean? That is nothing but arithmetic mean x bar is equal to sum of observations divided by number of observations. And you remember very important point is always sum by count is nothing but mean only. Sum by count nothing but sum by number of, that is nothing but mean only. Now what is sum of observation means? Here we are having the observations like x1 and x2, x3, so on, xn. So we have to add all the values. So x1 plus x2 plus x3 plus so on, xn divided by the number of observations is n, right? So this summation of all the observations simply we can denote as summation of, this is the symbol, summation symbol, xi, where I is 1 to n divided by n. So x bar equal to summation of xi by n. Simply we can denote like x bar is equal to summation of x by n without taking I also. So that is the mean of the formula for mean for an individual series. Of course we know that the data is divided into ungrouped data like individual series and frequency distribution like discrete series and continuous series. So I am giving the formula the first for individual series, that is x bar equal to summation of x by n. So from this formula we can conclude that summation of x is equal to, by taking the cross multiplication, this cross multiplication we can say that n into x bar. So what is this meaning? That is sum of observations is equal to number of observations into arithmetic mean. We can conclude like this. What is that meaning? So suppose we are having number of observations. How many observations? Suppose I am having 20 observations. I am having n equal to 20. Let it be their mean is x bar is equal to 5. Now the sum of the observations is equal to n into x bar, that is nothing but 20 into 5, that is going to 100. Now I don't know the values of these 20 observations, but I can say that what is the sum of the observations, sum of those 20 observations. That is means without knowing the values of those 20 observations, I am saying what is their sum. This is possible only when you are having the number of observations and mean. Okay, so we can find out the sum of observations if you have the value of n and x bar. So this formula is very important. Most of the problems we solve by using this formula only in arithmetic mean. So you should remember this formula is coming from the basic formula, that is x bar equal to summation of x by n. So summation of x equal to n into x bar, that is number of observations into arithmetic mean. Now coming to the next one is, suppose I am having the data like the observations, let the given observations are in arithmetic progression. So what is meant by arithmetic progression? That is, I am now giving you the general form of arithmetic progression, that is a plus d, a plus 2d, a plus 3d, so on, a plus n minus 1 into d. That is the general form of arithmetic progression. That a we call it as first term of the progression, arithmetic progression, and D is called as a common difference. Of course, the common difference between any two terms is same. That means T2 minus T1 or T3 minus T2 or fourth term minus third term will be the D only. That is, we call it as a common difference. If the common difference same only, then we can say that those terms are in arithmetic progression, right? And the last term we call it as simply nth term, that is A plus n minus 1 into D. And we know that the sum of n terms Sn is equal to n by 2 into 2a plus n minus 1 into D. That is the formula for sum of n terms in arithmetic progression. And here in place of 2a I can write a plus a. Now this a is the first term and this a plus n minus 1 into D is the last term. I am denoting with L, and first term I am denoting with a. So I can write the sum of n terms in arithmetic progression is n by 2 into a plus L. So this sum of n terms I can take it as the sum of observations. Sum of n terms is nothing but sum of observations. So summation of x equal to n by 2 into a plus L. So when the given observations are in arithmetic progression, so I can say that x bar is equal to, we know that summation of x by n. Now the summation of x I got n by 2 into a plus L divided with the number of terms, that is n. Now you can cancel n. So what you are getting, that is a plus L by 2. That is nothing but first term plus last term by 2. First term plus last term by 2. Right? That means if the given observations are in arithmetic progression, how to calculate arithmetic mean? By taking the average of first and last terms. How we can use this formula? I will explain with an example. So suppose I am having the data like this. Suppose I am having a variable x is taking the values 7, 14, 21, 28, 35, 42, 49. How many observations are there? 3 plus 3, 6 plus 7. 7 observations are given. Now I want to find out the mean of this data. Now we can observe that these are the multiples of 7. Of course, not only multiples of 7, those are in arithmetic progression with the common difference 7. Of course, multiple of a number definitely follows the arithmetic progression with the common difference with the same number. Now for the given this data, the common difference is 7 now. Now suppose if you want to use the formula, basic formula, what is that? Summation of x by n. That means you have to add each and every observation, these 7 observations, and you have to divide with 7. Instead of doing all these things, whenever the given observations are in arithmetic progression with a common difference, then we can use the formula x bar is equal to a plus L by 2. What is a? That is the first term, that is 7. And what is L? Last term, that is 49 by 2. So 49 plus 7, that is 56. 56 by 2 is equal to 28. Now you can add all these 7 terms and you divide with 7, you will get the 28 only. So this is the very important formula. It can be applied only when the given observations are in arithmetic progression. Not only this type of problems, we can solve one more type of problem. Suppose you want to calculate the arithmetic mean of, right, arithmetic mean of first 25 multiples of 5. Suppose the question is asked like this: arithmetic mean of first 25 multiples of 5. What are the first 25 multiples? That is 5, 10, 15, like that, so on. What is the 25th multiple? That is the last multiple. 25 into 5, that is 125. So these are the 25 multiples. Now you want to find out the arithmetic mean or average of first 25 multiples of 5. So suppose if you want to use the basic formula, you have to add all the 25 multiples and you have to divide with 25. So instead of doing all these things, directly we can use the formula, that is x bar is equal to a plus L by 2. Why? Because multiple of a number is also follows arithmetic progression only. So what is the first term here? A is nothing but 5. What is the last term? That is 125. So you can use the formula directly. 5 plus 125 by 2, that is nothing but 130 by 2. So that is going to 65. So 65 is the average of first 25 multiples of 5. In this type of situations, we can use this formula, that is the arithmetic mean when the given observations are in arithmetic progression. That is formula is a plus l by 2, that is average of first term and last term. That means that first term plus last term by 2. Not only for that, suppose if you want to take the arithmetic mean of first n natural numbers. Suppose I am taking the first n natural numbers. Of course, n natural numbers also follows the arithmetic progression only with the common difference 1. So we can use the formula again, x bar is equal to a plus l by 2. Now what is a? That is the first term is 1 and the last term is n by 2. So we can say that the arithmetic mean of first n natural numbers is n plus 1 by 2. Of course, we can say that one more way, the same formula we can prove in one more way, that is we know that the sum of n natural numbers, sum of first n natural numbers is nothing but n into n plus 1 by 2. Sum of first n natural numbers is n into n plus 1 by 2. So that is, we can take it as summation of x. So summation of x is n into n plus 1 by 2. Now we require mean of first n natural numbers. Mean of first n natural numbers is nothing but summation of x by n. That is n into n plus 1 by 2 divided by n. Now you can cancel 1 n. So what will remain? N plus 1 by 2. That is the mean of first n natural numbers. Otherwise, you can use the formula x bar is equal to a plus l by 2. You will get the n plus 1 by 2. So we know that sum of first n natural numbers is n into n plus 1 by 2. Like that only, we know that sum of squares of first n natural numbers, sum of squares of first n natural numbers that is summation of x is n into n plus 1 into 2n plus 1 by 6. What is the first square of first n natural numbers? What is the sum of square of first n natural numbers? Means 1 square plus 2 square plus 3 square, so on n square. That summation will be equal to n into n plus 1 into 2n plus 1 by 6. Now we know that summation of x, then we can get the mean. So because why? Because mean is nothing but summation of x by n, right? So n into n plus 1 into 2n plus 1 by 6, and now you divide with n again. Now you can cancel n. So you will get the formula is 1 by 6 into n plus 1 into 2n plus 1. We can write like this. So this is the formula for sum of the squares of first n natural numbers. Similarly, sum of the cubes of first n natural numbers, sum of cubes of first n natural numbers, that is 1 cube plus 2 cube plus 3 cube, so on n cube. That summation x we can write as n square into n plus 1 whole square by 4. That is the sum of cubes of first n natural numbers. So once you get the sum, we can get the mean of cubes of first n natural numbers, that is x bar is equal to summation of x by n, that is n square into n plus 1 whole square by 4 by n. So 1 n will be cancelled. So finally you will get n into n plus 1 whole square by 4. Suppose if you want to find out what is the mean of cubes of first 5 natural numbers. So n equal to 5 you can take. Then what you will get? X bar is 5 into 5 plus 1 whole square by 4. That is 5 into 6 square, that is 36 by 4. 36 4 9 times. So 5 into 9 you will get 45. So somehow mean of cubes of first 5 natural numbers is 45. So like that we can calculate the mean of first cubes of first n natural numbers by using this formula for any n natural numbers. Similarly, some mean of squares of first n natural numbers for any n natural numbers we can find out. Similarly, mean of first n natural numbers. Suppose what is the mean of 100 natural numbers? That is 100 plus 1 by 2. Mean of 50 natural numbers, 50 plus 1 by 2. Like that we can determine. So this is the use of this formula. So you should remember, very important formula. And also you should remember the main important formula, that is x bar is summation of x by n. From that we can say that sum of observations is equal to number of observations into arithmetic mean.